Hello, thank you for coming back for the second video of this calculus series. So this video I'm going to be introducing derivatives. So I'm going to start with a simple definition that we all remember from algebra. Slope. So the slope of a function is the rise over run. Is y2 minus y1 divided by x2 minus x1. That's pretty straightforward. Now in the late 17th century, a problem was trying to become solved, basically. Isaac Newton and Gottfried Leibniz both solved this problem at approximately the same time, where you're able to determine the instantaneous rate of change of something. You can find the slope of something at a point. So, whereas before you could find, so say we had a plot like this, you could find the average rate of change from here, but you couldn't find the rate of change from this point. And that became a serious problem, especially as we wanted to develop ways of mathematically modeling the physical world. So this is how calculus was born. And the way that we can do this is saying that we have a function. Let's call this function f of x. And we have some f of, let's call this point f of x. And then we want to find the slope of a line from here. Let's call this x1. We can say, so our second point is, the rise is f of x plus x1. The second point is f of x divided by x plus x1 minus x. Now we're going to kind of go smaller and smaller until we get to a point where we're essentially measuring the slope of a point, where we have f of x plus delta x minus f of x divided by x plus delta x minus x. Now, because we are going from this point to this point, basically an infinitesimal rate of change, we have to introduce the limit as x approaches 0, delta x approaches 0, of f of x plus delta x minus f of x divided by x plus delta x minus x. Now we can kind of do a little bookkeeping and rewrite this as the limit of delta x approaches 0 of f of x plus delta x minus f of x divided by, we can take x minus x, and we're left with delta x. This is the derivative. This is the definition of a derivative. So we're going to go straight into finding derivatives, and this is going to be something that's going to be taking the next couple videos. And what we're going to be doing first is developing some of these rules that you find in tables. I'm going to prove these tables to you, so you'll have a more rigorous understanding of the basics of calculus. So let's say we have f of x is x, a simple function. So we see this again here. We want to find df dx. So to find df dx, we have to find f of x plus delta x. F of x plus delta x, if we can remember from our pre-calculus / algebra, is that whenever we have something inside of the input, we replace any x in the output with this. So here we just have x, so we can put x plus delta x minus f of x, which is x, divided by delta x, and we need to remember the limit as delta x approaches 0. So here we can just set limit as delta x approaches 0 of x minus x. That gives us 0, so we have delta x divided by delta x. These are the same. So because we're not actually at delta x equals 0, we're at delta x is approaching 0. Delta x is an infinitesimally small value. So we can basically assume that these are the same value. This isn't 0 divided by 0. And we end up with 1. So the derivative of x is equal to 1. Okay, so I'm going to keep everything on this side of the board. And let's do a couple more examples. So let's say f of x now is x squared. So once again, doing this rule. F of x plus delta x. So the df dx. So we have dx squared dx equals x plus delta x squared. And then we have minus f of x minus x squared divided by delta x. And we have the limit as delta x approaches 0 of this entire function. So let's expand this. We have limit as delta x approaches 0 of x squared plus 2 delta x plus delta x squared divided by delta x. Minus x squared. So we can get rid of the x squared. And we have limit as delta x approaches 0. So the x squareds are gone. And we have 2x delta x plus delta x squared divided by delta x. Now, once again, we can manipulate this algebraically. We have delta x is on the top here. So we can turn that into delta x times 2x plus delta x divided by delta x, limit as delta x approaches 0. And we can get rid of these. And since this is in the numerator, we can turn that into 0. So that our dx of x squared is 2x. So those are a couple very quick derivatives. And in the next video I am going to define a few more using a few algebraic techniques. So what we'll be doing next time is for f of x equals x to the n, or if we have f of x, we can further expand this into f of x equals a, x to the n, where a is a constant. We can find the derivative of that using the binomial theorem. So once again, thank you for watching the second video on derivatives, and I hope to see you back next time as we work on even more derivatives. And once again, if you are learning along with a textbook, I would highly recommend doing as many problems as you can, especially with just using this equation right here. This equation is going to be important for while we're developing an understanding of derivatives. Eventually we'll get to the point where we don't need that anymore. You can either use a table, or you can you can just use a table, or you can use other differentiation techniques that we'll be talking about also later. So you can most of it's just using tables, and then it'll be applying things like chain rule, product rule, quotient rule, which we'll be talking about more as we go on with our derivatives. So that's it for this lecture, and I hope to see you back for video 3. Thank you very much.